this lesson, we're going to be looking at solving quadratic applications. So essentially, we're going to use what we have already learned about quadratic functions and apply it to solve word problems. So in example 1, we have Sherlock Holmes, who is watching after bees, and he has given us a path that the bee follows from flower A to flower B. So on the graph here, I'm going to just go ahead and label my y-axis and my x-axis. We can see A and B, the two different points that he has modeled the path in between. And the path that he has modeled is this parabola right there, which is given by this equation here. And we do know that that is something quadratic because the highest exponent that shows up is 2. We can also tell that that parabola will open downward because A is a negative number. We can see that negative in front of the x squared. So the first question we're being asked is, what is the maximum height the bee reaches as it flies from A to B? So as the bee flies from A to B, we can see that it's going to reach its max height at this point. And that point is going to have an x value and a y value. We are specifically being asked for the maximum height. So what we want from that point is we want the y value. So the answer for part A is going to be the y coordinate from the vertex. So that we know what we want, let's talk about how we'll find it. So we need to know what the vertex is, what that point is. Back in a previous lesson, we saw a couple of ways that we could find the vertex. One way we can find the vertex is by writing the quadratic in vertex form, going through the process of completing the square, which would be particularly messy, or could be particularly messy in this example because of the decimals that we have going on. Another way that we can find the vertex is by using the vertex formula. And remember, the vertex is a point xy, and what the vertex formula tells us is that the x coordinate of the vertex is equal to negative b divided by 2a. So we can identify a and b from this quadratic. A is what's in front of x squared. A is equal to a negative 0.03. B is what's in front of x. B is equal to a 1.8. So I'm going to be plugging in here. So this is a negative 1.8 divided by 2 times negative 0.03. Do make sure to take your signs with you when you plug things in. So that comes out and gives me an x coordinate of 30 for the vertex. So far we know that this point is the point 30 something. So we know where the maximum happens. We know where it happens. We know the x value it happens at, but we need to figure out what the maximum is. So now to get the y coordinate of the vertex, to get what the max height actually is, what we're going to do is we're going to take the x coordinate of the vertex, which is 30, and we are going to plug that into the function f. That is how we get the y coordinate of the vertex. We take our x coordinate and we plug it into the function f. So I'm going to be plugging in 30 for all of these x's here in the original equation to give us a maximum height of 3. And this distance is in inches, so I will answer that our final answer here for the maximum height that the bee reaches between those two flowers is 3 inches. Moving on to part B. Part B asks us, how far away is Sherlock from flowers A? How far from Sherlock are flowers A and flowers B? So looking at the graph here, what we want to know, I'm going to erase this because we're no longer interested in the max height. What we want to know is, what is this horizontal distance here? How far is Sherlock from flower A? And what is this horizontal distance here? How far is Sherlock from flower B? Well, because Sherlock is along the y-axis, really all we need to know is what is A and what is B. What are the x-intercepts of this quadratic function? So to find x-intercepts, we need to set the entire function equal to 0. So we essentially need to find the value of A and B. So we are looking for x-intercepts. And the way we find x-intercepts is we set the function equal to 0. So I'm going to solve the equation 0 equals negative 0.03 x squared plus 1.8x minus 24. Now at this point, solving this quadratic equation, the methods that we have discussed are factoring, quadratic formula and the square root method. When we are solving a quadratic application problem, I have no problem with you just going ahead and applying the quadratic formula. So I'm going to go ahead and apply the quadratic formula, which says that x is equal to negative b, so that would be a negative 1.8, plus or minus the square root of b squared, so that's 1.8 squared, minus 4 times a, which is negative 0.03, times c, which is a negative 24. And then this is a 0.3. That still looks strange. All of this is divided by 2a. So this is all divided by 2 times negative 0.03. And so now I'm going to evaluate this and see what we get. I would recommend that you start by just finding the number that's under the square root. So I'm taking 1.8, squaring it, multiplying it by negative 4 times, taking 1.8, squaring it, and from that subtracting 4 times negative 0.03, multiplied by a negative 24, which comes out to give me a positive 0.36 under the square root. And then in the denominator where we have that 2 times the negative 0.03, that just comes out to be a negative 0.06. So I'm going to go ahead, and that's not a 36, that's a 0.36. I'm going to go ahead and separate these into two separate expressions, one with the plus and one with the minus. And then I'll punch both of these into my calculator individually. This is a negative 1.8 to get two separate answers. I get in my calculator are 20 inches and 40 inches. And so that tells us that Sherlock is 20 inches away from flower A and 40 inches away from flower B.